Thank you, Charles, and thank you everyone for being here. This is a topic that really needs for citizens to begin to speak up and to express their concerns and their interests. My name is Mitch Trachtenberg, and I'm here to bring you good news from Humboldt County about election integrity. I'm a non-felon, for starters. I'm also a volunteer with Humboldt County's Election Transparency Project, and I'm the creator of some open source vote counting software. I'm sure there are others as well. And I feel awkward being the one person from the Transparency Project that's doing these talks. So let me just make some acknowledgments right up front. First of all, it's not really about the software. It's about the access to the ballots. And the access to the ballots is made possible by our Registrar of Voters. So Carolyn Cernich is the Humboldt County Clerk and Registrar of Voters, and she is one of us. She is a volunteer with the Election Transparency Project as well as playing these roles. She does scanning as well. And it's really through her that we've been able to do this project, because she's the one with the keys to the kingdom. Kevin Collins is a commercial fisherman in Humboldt County, and Kevin Collins approached Carolyn Cernich a couple of years ago and said, how come we don't get to look at our ballots? How come we can't count them ourselves? She said, I don't know. And that was the start of the Transparency Project. She decided that we should have the right to look at the ballots ourselves, and they began setting about looking for ways to technically accomplish that. Tom Pinto is another very active volunteer. He's with the District Attorney's Office, and there are many people who come in for scanning ballots as volunteers. This will be the first election during which people will actually get paid for scanning ballots. Until now, it's been entirely out of people's sense of citizenship. I'd also like to thank Lori Grace of the Grace Institute for Democracy and Election Integrity for making it possible for me to come down, and she's making it possible for me to do this sort of presentation in various places. So a couple of key points to start off with. Everybody believes in a secret ballot. Everybody wants for ballots to be cast in secret, and there's no question that we all agree with that. But after the ballots are cast in secret, and after they can no longer be traced back to someone, they should be public documents, and they should be countable by anyone. There's no reason to keep them hidden. The technique that we've used to enable anyone to scan ballots, anyone to count ballots rather, is to scan them. We use a commercial scanner. We generate the image files that are necessary, and we put them on the internet for people to count themselves, or you can get them on a DVD from the elections office. Now, let's talk about why it's important to have redundant counting. Think for a second about hand counting. Imagine that what you were doing was having all of the ballots in your election hand counted. Let's think about this approach. Let's go find the most respected judge in the county, Judge Jones. And we're going to hand all the ballots over to Judge Jones, and we're going to ask her to count them. And Judge Jones is going to go off into an office somewhere, and Judge Jones, very, very respected, is going to count the ballots and determine the vote, and is going to say to us 472,000 for so-and-so, and only 471,000 for thus and such, and that's the result. How many of us would be happy with that? It's not sensible. You don't want one person counting the ballots. It doesn't matter how respected they are. You want a check against that person. You want to make sure that somebody else, maybe with different interests than Judge Jones, is looking. That's not a challenge to Judge Jones's integrity. That's Ronald Reagan. I mean, trust but verify. You want to make sure that there are at least two sets of eyes on those ballots. Well, it should be the same thing with computers. Right now, the approach that we've been using is to try to develop this incredibly secure computer system and put all of our trust into that incredibly secure system. Some people think it's really secure, some people think it's not so secure, but either way, we're putting all of our trust into that system. And as far back as 1975, in a key paper that was written back then by Roy Saltman, at the dawn of computers in voting, it was just assumed that there would not be one computer doing the counting. It was assumed that you'd have two different computers under the control of two different elected officials doing the counting. Because redundancy is not a shocking concept. Redundancy is something that we all understand the importance of. When we fly, we want our airplanes to have redundant instrumentation. So if one altimeter goes bad, at the very least, you can look at the other one and see, well, wait a minute, I'm getting different results from these. There must be a problem. In a mission-critical situation, an engineer will insist that there be three instruments, three copies, so that if one of them goes bad, the other two will still be consistent, and the one that doesn't agree is shut down for repair. So redundancy is something that we understand. It seems everywhere, except in machine voting. Our solution to enabling the redundant counting is to scan the ballots, make the scans available, and then I've written some open source software that just counts the votes off those scans. You don't have to use my software. Anyone can write software that will count votes off the scans, but I just wanted to make sure that at least one such item existed. But this is the sort of project that could be done by a computer science class as a project. It's not enormously difficult. Now, I think there are a lot of very talented and very good computer science people who are working on the wrong problem. They are trying to develop an ultra-secure system that will leave computer scientists convinced that the vote was counted without fraud and accurately. And they're sort of assuming that once the computer scientists are convinced, they can announce to the world that the votes are being counted properly and everybody should be happy. And that's the wrong problem. What we need is for everybody to understand what's happening. The counting system needs not to be totally secure, but to be redundant and simple, so that anybody can look at it and realize for themselves, well, they did this and this and this. Makes sense, so I trust the vote. No magic, no reliance on experts. And it sometimes seems that the computer science people are much more interested in the more complicated solutions, in trying to create an ultra-secure system. You can create it, it can be ultra-secure, it can be the best thing since sliced bread. Maybe nobody will ever break it, but how will we know? How will we know? Redundancy offers us an opportunity to see, right, this one said this one also says this, it's okay. So a little bit of history about the Election Transparency Project. I already told you Kevin Collins approached Carolyn Cernich and said, why can't we look at our ballots? I met Carolyn in early 2008, I think it was, and we got to talking. I'd actually already had contact with the other people in the elections office who had kind of blown me off. You know, I became one of those crazy election integrity activists. But then I met Carolyn, and that person, by the way, is gone. But I met Carolyn, and we got to talking. It was in a totally other context. And somehow we got onto the subject of election integrity, and we found ourselves egging one another on. Yeah, why don't we do that? And I decided, you know, I would make sure that the resources, the technical resources, would be available if she was willing to go ahead with this sort of thing. So I agreed that I would develop whatever technical software was necessary. We did our first run in early 2008. That was just a dry run to make sure that it was working, and it did. So in November 2008, that was the first real use of the system. And what happened was all the ballots were taken from storage up to be scanned again. And Carolyn and Tom and Kevin and lots of other people and myself were scanning them through. And it was very, very dramatic. It took, to run everything through the scanner with volunteers, this was a first run, took us basically right up to the time when Carolyn needed to certify. And so we were in the scanning room on the Sunday before she was required to go before the Board of Supervisors to certify. And she began worrying that we weren't going to come up with enough ballots, that, you know, the counts wouldn't match. Forget the votes, let alone, you know, just we weren't going to have enough ballots. And we kept going, and I said not to worry. And then as a joke, I said, what if we have too many? Sure enough, we had 200 ballots too many. There were 200 ballots that hadn't been accounted for in the numbers that were coming out of Diebold's AccuVote system. And a kerfuffle followed. Carolyn rather, contacted Secretary of State Deborah Bowen, and her office started a substantial investigation. You can find, by the way, the results of that investigation online at the Secretary of State's voting systems webpage. It's Secretary Bowen's report to the Election Advisory Committee on the Humboldt situation. It has a name, something like that. It's a 40-page report, very thorough and very good. What had happened was this. The Diebold system had a bug that had been known about for 4 years. And to explain that bug, I'm going to back up for a moment. When you're running ballots through the AccuVote system or through the Diebold system, you divide the ballots into batches or decks, and you feed them in. And if there's a misfeed or a double feed or something like that, then you take that batch and you delete it, and you rerun it. So deleting a batch of ballots is a very common thing. It's not unusual. Well, with the Diebold AccuVote system, when you deleted a batch of ballots for the first time, let's say it's the 312th batch that you've scanned and you're deleting it for the first time, it will delete batch 312. It will also delete the very first batch that you scanned, and it won't tell you that it did that. So this was a bug that was known. The elections officials in all the counties that used Diebold had been notified of this bug. There had been an email that went out, and it was one of those classic corporate emails, that says, oh, by the way, if you want this to count properly, then you have to do this. And then it said, as a workaround, what you should do is scan a batch, delete that, and then rescan it. That should be the very first thing you do in counting. And so sure enough, that email was sent and received by someone in the elections office 4 years ago, and 4 years before. And then they left. And nobody who was in the elections office had that email. It was never put into the procedures. It was just something that we'd like to think that person did. We don't know for sure that that person did it. And so there was no knowledge in the elections office. Even though California had conducted a top-to-bottom review of all election systems that were used in the state, Diebold had never sent that email to anyone in the Secretary of State's office. They just sent it to their colleagues in the elections offices. And so what happened was we got bitten by that bug. And in fact, I think it was exactly 192 ballots were dropped from precinct 2045 in Eureka, which is the big city where we are. And there was simply no record of it. Now, it's true that if at the very end of the process there had been a reconciliation, it would have been caught. But what Carolyn had done was she'd gone through half of the ballots, she'd gotten printouts about them that confirmed their results. She was relying on those printouts, and then she did the next half of the ballots and added the two numbers together. And it's a good thing she got those printouts, because otherwise she would have probably been blamed for this. But what happened was the numbers on that first printout were no longer the numbers that Diebold was recording for those ballots, because there had been that deck 0 error. The deck of ballots had been dropped. And I'm not saying that there's been any fraud in connection with this. I have no knowledge of whether any fraud has taken place in connection with this bug or any bug. But think for a second about what the situation was. Elections officials had been notified that the first deck of ballots that is scanned, which they have control over what goes in that deck, and it can be any number of ballots, the first deck of ballots will be silently dropped when you delete another deck. And it's just, let's leave it at this. It's not good practice to leave things that way. Now, why was it probably left that way? Why was that bug not immediately fixed? It's kind of a good idea that's stabbing us in the back. It's the certification system. The certification system, in an attempt to make these machines secure, says that anytime you make a change, you need to recertify it. And that costs about $500,000, I'm told. So nobody's doing bug fixing if they can do workarounds, because they don't want to spend $500,000 to change a line of code. Just as a quick aside, when I was in another county scanning for another project, the technical guy at the county told me how nice it was that we didn't have to restart from the beginning of a batch every time there was a double feed. We could just pick up. And I said, well, wait, we're using the same exact system that is used by your commercial system. And he said, yeah, but the commercial system is still using 5-year-old drivers. Why? Because they compiled those drivers in and they can't change the system because it would cost them $500,000. So we had our little moment of fame, and we got written up, and I think there was like 5 seconds on some national show, and it became another of those isolated instances that we seem to have thousands and thousands of isolated instances, and it's always being fixed. It's always called a glitch. So in Humboldt, volunteers have scanned every ballot cast in the county since that, because we were a little surprised. I was shocked. I didn't get into this to catch Diebold. I got into this to justify the idea that paper ballots were better than ATM-style voting. With paper ballots, you can do an additional count. And I figured one way to help people justify paper ballots, instead of just saying, look, with paper ballots you can do an additional count, do an additional count. And I thought it would come out the same. I was really very confident that it would come out the same. And I don't think anybody was more surprised than either Carolyn or I when the numbers came out wrong. We both assumed that we had screwed up. We didn't think initially that this was a Diebold problem. So what's the process? It's really a very, very straightforward process. The transparency project is really about the first 3 steps of this, and then I wrote software to enable the 4, 5, and 6. But the first thing is just run the ballots through a regular, common, commercial office scanner. And ideally, you can have a printer on that scanner, so that as each ballot goes into the scanner, it gets a serial number printed on it. Then take the images that you have from the scanner and save those images to a disk, a CD or a DVD. But as you save them to disk, to ensure that the images can be confirmed to not be altered, you can go through a process called digital signing. And digital signing is not like when you go into a Kmart and sign on one of those little screens. Digital signing is a cryptographic technique that ensures that a signature will not validate against a particular data file if that data file even has 1 bit altered in it. And the American Bar Association says that digital signatures are more reliable than paper signatures. So it's completely approved as a way of ensuring that something hasn't been altered. So save the signed images to disk. And then, and this is an important step for those of us who are a little paranoid, once you have those images signed and on disk, take it out of whatever you used to create that disk, put it in another machine, and have somebody say, I'd like to see ballot 232. And bring up ballot 232 on the machine and go, if the paper's still out, you just scanned it, look up 232 and compare them. And now the disk is already out of the machine. So if the disk can be spot checked and the images on the disk match the images on the paper, then you know that you have that the system hasn't cheated you. The system hasn't put phony images on the disk. Once you've got that, the idea of the Transparency Project was make those images available to anyone who wants to look at them. So for example, let's say you were running in a supervisorial district. You could get all the ballots for that supervisorial district and count them yourselves. And maybe that would be less expensive than ordering up a recount. Maybe you could do a little test count to determine whether it would be worth it to do a recount. And in fact, that's already happened in Humboldt, where people have been satisfied by the existence of these disks and decided not to go to the expense of asking for a recount. The software that I wrote then takes these 4, 5, and 6. Basically, if you look at a ballot, here's a Diebold ballot. I'm sure you all know what ballots look like, but here's a Diebold ballot, and you can see that the contests are boxed. And as it happens on this particular style of ballot, the vote targets are in red, and there's registration marks down the side in a very consistent way. And at the bottom, there's a pattern of dashes. And that pattern of dashes tells you what kind of ballot this was. So depending on which precinct you're in, you might have a ballot with a different print job than those from another precinct. So there's a lot of information on that ballot that can just be computer extracted. We can go in, and the first time we see a ballot with this particular dash pattern, we can go in and grab all the boxes, and then grab all the vote targets, and then run optical character recognition software to capture the names next to the vote targets. And that takes a while. That takes about 30 seconds for one of these. And then you have a template that you can use to check all the ballots of this type. And checking the individual ballots is instant. It's far faster than scanning them. So it's just 30 seconds up front per ballot type. And once you have those templates, you use them to determine the darkness of the image at the vote targets. And dark enough equals a vote. And then you're able to provide ballot by ballot results in spreadsheet form. So whereas the commercial systems are just telling you it was 237, 152. What this system does is you have the images, you have the extracted data from the images, and you have the final results. And you can go back and check each of those things against the other. Now, how is it possible to do this? It was possible to do this because most of it already exists. And most of it, or all of it, is free. It's out there, it's available. This is all built on a platform of what's called open source software. And open source software exists in all of these areas. Basically, you have an operating system that you can replace Microsoft Windows with. Actually, what's running on this computer now is Linux, not Windows. So you have Linux. Digital signing is out there for free in a program called GPG, GNU Privacy Guard. Scanning capability is out there in a protocol called SANE. Optical character recognition. This program was developed by HP Labs, but they decided they couldn't make money on it, so they released it into the public domain. It's called Tesseract. It's free. The language to write the programs in is Python. It's free. It's available. The image processing, PIL, Python Image Library, is out there, available, free. Spreadsheet, OpenOffice, out there, available, free. And if you wanted to import it into a database, then there are at least 2 free databases that have full support for the standard database language, SQL, structured query language. So all of that exists. And so I took all of that and I modestly named it the Trachtenberg Election Verification System. What TEBS actually does is it adds a little bit of ballot processing, but for the most part it's glue that connects all of this stuff that already existed. And I won't bother to show you what it looks like to scan stuff in, and the extraction of the data is not particularly interesting to watch, but once you've done all of that for an election, you can go and say, go to any ballot number and bring it up and take a look at what the software calculated as the results on that ballot. So what you're seeing here is ballot 259, and as I said, as they go into the scanner, they get a serial number printed on them. So if you're not sure, let's zoom this out a little bit, and here's your 00259 serial number, so that's the one. And what it's saying, I think you can see that there's a green fringe around these boxes. That green fringe is telling you the area that it thought the vote target was at. And this blue is telling you what was OCR'd off the template. It's telling you that it thinks this green vote target is about Lawrence Larry Naratelli, and I can hide that for a moment so we can look at the underlying ballot. So I'll say, let's not see that, and there it is on the ballot, Lawrence Larry Naratelli. Let me put those back. And when something's dark enough, it just shows it in red. So you could imagine taking this system or some system like it and scanning ballots in an auditorium, and the extraction is instant. So this can be running just a ballot or 2 behind the ballots that you're scanning in. And this could be projected up on a screen. And if you wanted, you could have 20 people where 2 of them were counting governor, 2 of them were counting lieutenant governor, 2 of them were counting insurance commissioner, and they could do their own counts. And they could say, well, I agree with the software on this one, and this one, and this one, but wait a minute, not on this one. Or you can just rely on the software. I mean, it's up to you. I'm going to put this into auto advance mode, and you'll see it'll go by. And you'll notice that the ballots are slightly differently tilted from one another, and they're slightly offset from one another. The number is changing here. And as it goes through, you know that was a different ballot type. So now we're on a new ballot type. And well, let's stop. If I back it up, I think we can see some OCR problem. I bet I'm never going to find it again. I saw Scott go by, and Scott came out SCO and then 2 quote marks instead of 2 T's. So you get those sorts of OCR errors. And that's the system. Now, I'm going to go nerd on you for a moment. I just want you to see what's underneath that. So if we, here are the JPEG files. Here's an example of the images. But if I go to the results directory, I can show you what an individual result file looks like. I'll just go to 1181.txt. And this is very intimidating to those of you who are not computer people. Basically, these are really long lines. So these 3 lines are just one line. And all this is telling you is that in file 1182 JPEG, it found this kind of ballot based on the barcode, and it found a contest for sheriff. The text read sheriff, and then a new line, vote for 1. And the candidate that it's looking at is Mike Downey, and underneath Mike Downey it said under sheriff, and the OCR missed a little bit, so it came out UNDCR sheriff. And then you get the coordinates at which that vote target was, and this number here, 145, is telling you on a scale of 0 to 255 how light or dark that spot was. And 145 is basically light. It's not all the way to the top of the scale because it's got that black box. So it's light enough so that we can say false, this isn't a vote. But this next one, Michael Hislop, he's at 99, 1775, and he was darkened to 58 on a scale of 0 to 255 with 0 black. So 58 is dark enough to be a vote, that's a true. And the last part of the system is just to go through all of those files, merge them together, and count. So if I go to here, I'll just show you a very unpretty vote total. But this is the underlying stuff. Okay, we had a candidate called Abel Maldonado. He's not just called that, that's his name. And he got 5,069 votes. And there were a couple of misreads where the name came out with a D instead of an O, and a 0 instead of an O, and an E instead of a B. So you would either need to have some other process come along and merge all that, or you could just add it yourself. Okay? If we go to Barbara Boxer, okay, Barbara Boxer in this particular race got 13,078, Bill Lockyer got 13,712, and so on. And there are going to be these one-offs, and we'll work over time to minimize them. But you just need to, you can be routed to the ballot. It can tell you which ballot is responsible for those one-offs, and you can look them up and solve them yourself. So that is the result that you get, and you can add stuff that will make that pretty or format it in any particular way. It doesn't have to look as ugly as that. So what we have now is we have optical character recognition being used to build the ballot layouts from the image. And that's the sort of thing that none of the commercial companies that I know of are doing. They all still sell you ballot programming services. So you sit down at the beginning of an election and you have to manually enter all this information, but this free stuff just gets from the ballot itself for you. Now, think about it for a second. I mean, why would they do it automatically when they can sell you the service? You know, there's no reason for them to. But when you're talking about open source software, it's not being done to sell stuff, it's being done to work. So let's automate what we can automate. And it automates the counting. I'd say you get 98% or more of the votes, and you have to inspect manually 1 or 2% of the ballots. As you just saw, it shows you the ballots overlaid with the votes as determined by the software. It can report to you the ballots or votes that need a manual count. And as an additional service, anytime there's a marked write-in, it just captures the image of the write-in and builds mosaics of it so that you can get sheets listing all the write-ins. And coming real soon, I'll finish the documentation and so on. Any of you who are listening to this probably are thinking, wow, I wonder if it could do this, or if it does this, or, well, all of that, you know, the bells and whistles, the improvements, all of those can be added. I can add them. But also, because this is open source software and anyone can look at what I've done, anyone else who's a programmer can add them as well. So one of the reasons that open source software evolves at such a more rapid rate than commercial software is you don't just have a group of 20 people working on it, you have a group of 20,000 people working on it. Now, there have been concerns raised about this, and I'm putting these up not just because I love arguing, though I do, but I'm putting this up because I want you to understand that we're aware of the concerns and we have responses to them. That's not to say that the concerns aren't real. The concerns are in many cases very valid. The strongest concern that people have with this system is you lose what's called strong privacy, or what I've called here enforced privacy. Imagine that you have a wife who's abused by her husband, and the husband says to the wife, "You'd better vote this way, and I'm going to, you'd better vote this way, and I'm going to be able to check, because what I want you to do is fill in the top half of this vote and the bottom half of this vote, and then I want you to put a little dot just to the left." Okay? Well, with private ballots, with those ballots not being exposed, that's no risk. But with a system like this, particularly if it's out on the internet, there's a risk that that husband could go through all the ballots and find that, and if he doesn't find it, then the wife's in trouble. Well, that's a very legitimate argument. That's a very legitimate concern. Here's the thing, though. It's also a concern about vote by mail, because that husband could just tell the wife, "Give me your ballot," you know, and now you have to sign it, and I've filled it out. So vote by mail has introduced a real problem with respect to enforced privacy. It has introduced room for people to extort votes, for people to sell votes, and that's real. And that's a huge hole. This introduces the exact same hole, just a teensy bit. So since we've already gone to vote by mail in California, there's simply no reason to worry about this unless we're planning on going back from vote by mail. That's never going to happen. Once it's out of the bag, it's out of the bag. So I think vote by mail is the answer to this first concern. Then there's a lot of election law, a lot of voting law that is simply ambiguous. And it would be really helpful if it were cleared up whether or not you're allowed to print numbers on ballots. But, you know, sometimes people who don't want to do something will find any excuse not to do it. And so they'll use an argument like, well, I'm not sure if we're allowed to print on. Well, okay, don't print on the ballots then. Okay, instead of printing numbers on each ballot, then every 25th ballot, put in a blank sheet and just print the number on that and keep the ballots in the same sequence so you can still get back to the paper. I mean, the thing is, the slightest amount of thought will show that some of these problems are not real, and yet you're going to hear them. You're going to hear them cited as, oh, we can't do it. And when you hear those problems cited, it very often means, please don't bother me. I know what I'm doing, you know. Cost. We're in very tough times right now, but the software is free. You can use regular commercial scanners, and you can do this on laptops. You can even do this on a netbook. It would be a little bit slow, but it would probably still be as fast as the scanner. So the cost, it's true, it's not zero, but it's negligible if you truly have an interest in doing this. You can make it happen. And then here's one that always comes up. What if the second count is wrong and the first count was right? Why cause ourselves all that trouble? Well, that's true. It's true. It's very possible. In fact, that was our assumption the first time when we came up with those additional 200 ballots. We figured we'd blown it, not that the original commercial system had blown it. If the second count is wrong repeatedly, you're probably going to stop doing this, or at least you're not going to do it with that system. So that's a problem that will go right away. But it's the wrong question. The question that you should be asking is not what if the second count is wrong. The question you should be asking is, what if the first count is wrong? Right now, there's no way to find that out. Because while the second count gives you these images with numbers on them, and shows you how those images connect to spreadsheets that you can look at, and shows you how those spreadsheets calculate up to a vote count, the original system says there were 272,519 votes for John Jones. Believe it. Believe it. Well, how can you believe it? How can you believe it when there's no other system telling you, yeah, that's about what the number was. I came up with 3 different because I treated marginal votes differently. But yeah, it's close to that. Good work. Without that, there's absolutely no way to know. No matter how secure you make the system. Because even if the system is completely secure, you can't know that. You can never know that 100%. Because every time somebody tells you that something cannot be broken into, what happens? It's broken into. So redundancy. Redundancy is the simple answer. And that's what this is doing. It's saying, let's count twice. We do it with everything else. Let's do it with our votes. They're important too. So these are a couple of websites that have more information, and I'd be happy to take any questions. Yes?
I've told this story, I've narrated this story to people in San Francisco, and then a question I keep getting again and again is, how did you get access to the ballots?
Carolyn Cernich.
How did she?
She's the registrar.
Because I keep hearing that they're
Right. How was she able to grant us access to the ballots?
right.
Well, we all went down to Sacramento before we did any of this, and we met with the Secretary of State and with many of her deputies, and we said, "Won't you please tell us we can do this?" And basically they said, "Can't you hear we're not saying no?" And we took that as fine. And Carolyn was very willing to stick her neck out because this is something she believes in. And she's a smart, smart woman.
So there was no triggering event for you to do your count with your system. You were just, you only learned of the 200 drop ballots after you did your count.
Oh yeah, right. There was no triggering event. The idea of doing this was Kevin Collins.
Prophylactic.
Yes, yes.
No, but if you count the ballots before they are certified, you shouldn't have a problem, because California law says that after the votes are certified, after the election results are certified, which is 28 or 30 days after the election, after the results are certified, the ballots have to be, put under lock and key, and they can only be opened in case of a recount, or court. So if these ballots are scanned, which I believe they should be, between election night, and you have the provisionals coming in, you have all the overseas ballots coming in, and you have all of those thousands of ballots, of absentee ballots that are dropped off on election day that still have to be counted. So if this scanning is going on continually between election night, Tuesday and Wednesday morning, and in that interim, then access to ballots shouldn't be a problem. But I also think that election laws across the country should be changed to require that, to define voted ballots as public documents. But that's the workaround, right?
I'm about to get myself into trouble.
That's okay.
During a meeting with some high officials, we were discussing whether or not the ballot containers could be opened, and an official somewhat exasperatedly said, "As far as I can read it, we're not allowed to open them to count them the first time." We just don't, the law needs a rewrite. The law is not well written and not clear.
Well, because the law is ambiguous, what that means is that the local election official is empowered like a czar or czarina. They can say, I read it this way, I read it that way, there's no accountability, there's no oversight, and they can decide what to do. In the case with Carolyn, it was good that she decided to put her neck out on a limb for what I think was a very worthwhile project.
I'm sure people are familiar with a very basic government type. You know, there is a type in government who's a bureaucrat who really just does not want to be woken. And they sometimes, you know, they will come up with very reasonable explanations of why absolutely nothing can ever change, ever. And you can argue with them, but they're the ones with lifetime tenure. You know, there's nothing to be done.
But that's the problem. They're a bureaucrat when in fact they
What
are
you
public.
need-
No, they are public servants. I talked to Carolyn for the first time, you know, within the last couple of weeks, and you know, hi, my name is Eva Moscal, like blah blah blah. The first words out of her mouth were, "Everybody here trusts me," and wow, what a statement
She
to
is
be
the most
able
popular.
to make. What a statement to be able to make.
Carolyn
People
Cernich.
trust her.
Carolyn Cernich is probably the most popular elected official in Humboldt County. And that's because she did make a mistake. I mean, it's not because she's perfect. It's because she made a mistake and corrected it. Can
In
you
public.
imagine? Yes, in public. That's what we want of our public servants. We don't
Yes.
want an office to hide the sausage making. We want the sausage making to be out in public. Now, the worse the process is, the more people are going to resist making that public. And so I think you'll find that the better the elections office, the more transparent it will be. And we really are incredibly fortunate in Humboldt to have Carolyn Cernich. And we know it. I mean, the newspapers have editorialized in praise of her and the project. She was just reelected. I didn't check the count, but she was reelected by a lot. And you know, she's well liked and well admired. And yeah, by me too.
The 1% manual audit that's required, maybe could be used for 10%?
Yeah, and it's being used, I think. It's being picked up on as an idea, not original with me by any means. There's a paper by someone who I've never met, Calandrino, that preceded the Election Transparency Project that was recommending this approach for election audits. Another thing that you could do if privacy concerns are being raised as a stumbling block, or vote extortion concerns, I'm not recommending this, but as a way of salvaging the thing, if you have that as a roadblock, what you can say is, all right, let's scan them all, count them all, and release only a random 10% based on a roll of the dice. And that way, that husband he won't be able to say you didn't vote, because he'll only be seeing 10% of the ballots. But really, kind of the best approach is release them all.
Yes.
There's one other thing that I realized I left out, and that's this. Where I'd like to see this go, and I recognize that it's way off in the future, if at all, I'd like to see this done at the precincts at the end of polls. So something like this is a $1,000 scanner. Here's the scanner part, here's the printer part. You can run this, take 20 ballots a minute. And so if you had someone come in an hour before close of polls at every precinct with one of these, then it would take them a half hour or so to run a typical precinct through it. They could generate a signed DVD. That signed DVD could then be dropped in a mailbox. And all of your chain of custody issues about what happens to ballots once they leave the precinct, done, because you have a second copy of those ballots. And so, that's sort of the ultimate place. Right now, auditing is by far, I think, the easiest sell, because that's still in the club. And then after auditing, you have the idea of doing a central count facility where you have one big machine or 10 big machines. And in my fantasies, you have one of these sitting at every precinct. And there are problems with that. The walk away is the most simple problem.
Yeah.
But other questions, comments? Yes?
I have a question where you were talking about putting the batches through the machine. and that they jam, and that happens with some frequency. So if you're scanning through and it's batch number 212, right, and you say it deletes it, then when you scan it through again, does it become 213?
You're talking about the commercial software?
Yeah.
The answer is I don't know.
Okay, and then then you said that when it deletes it, it also deletes the first one. But is that only the first time you delete a batch? Or is that every time you delete a batch? Does it go back and delete the first one?
I don't know the answer, but I suspect it's only the first time.
Okay. But it just keeps deleting the first batch.
Yeah,
Okay.
I only think that, well, you know, I'd like to think that the outrage would have been even more, but who knows? Why should you be more outraged about losing 2 than 1? One's bad enough.
But you said that with the commercial app software that it does jam with some frequency.
Any scanner is going to jam. Yeah. Yeah.
Thank you.
Yes.
But the jamming problem is only when you're doing the second scan, because when it's initially scanned at the polling place, if it's going to jam, you know right away when you're inserting your ballot. So you're talking about the second scan.
I'm talking
and
about.
So they could, so you could actually still compare the data that is on the disk to what happens when it gets back to whatever headquarters it's going to.
That's true.
Because you already have the initial scan.
That's true. Yes. Other questions or comments?
Well, wasn't there some function in the Dieball machine where you could delete the records of?
Oh yeah, I didn't talk about the audit logs, did I?
No.
See, that's the problem with doing the presentation twice. Yeah. Going back to November 2008, when the Secretary of State came in because we turned up with 200 ballots that weren't accounted for, the Secretary of State did an investigation, found this Deck 0 problem, found the emails that had gone out and so on. But then, to their credit, they kept looking because they wanted to find out more. And so what turns up but a button in the Diebold user interface enabling you to delete, I don't know whether it's all the audit log or part of the audit log, but you push a button to delete a chunk, at least, of the audit log. Well now, an audit log by definition is something that you can't delete. And even Diebold knew that because the Secretary of State turned up email communications from one of the programmers who had put it in for testing, you know, saying, let's be sure and take it out. And the management decided not to take it out. So there you are with a button in the user interface inviting you to delete the thing. The audit log, I mean, maybe it doesn't quite register, but the backstop that these companies have been asserting for decades now, the absolute fail-safe is, hey, if we do anything wrong, it'll be in the audit log. Well, it turns out you can delete that audit log, but it's worse. You know how when you're using Microsoft Word and you want to exit without saving, it says, are you sure? Well, not with this. So it comes up on the user interface, delete the audit log, you click OK, it's gone. It's not recoverable. There was no confirmation request. And you might think that that would mean that somebody would do it by accident, and in fact somebody did. I don't remember which county it was, but the Secretary of State found that this problem had actually occurred. And it wasn't critical at the time, or at least as far as anybody knows it wasn't critical. But what are you doing with, I mean, this is the stuff that we're paying millions and millions and millions of dollars of taxpayer money for. To these companies, there's 3 or 4 companies that completely control the industry. And, no, enough.
Just on a historical note, the ballot tap machines, which came out in the late 60s, early 70s, had this feature. So it's been around.
Wow.
And all of this, in all of the systems, and all of these systems that have been certified have all passed with flying colors. Nobody noticed. You know, this is like approving, you know, test driving a car, you know, for the wheel pressure and failing to notice, you know, gee, there's no steering wheel. I mean, it's that blatant.
But it's certified though.
Yeah.
Can we get an email of this presentation?
Donnie? Oh, just this?
Yeah, your
The
PowerPoint.
PowerPoint,
Sure.
I think you basically have it. It's the same thing as San Francisco with one slide inserted. But yeah, I'll email it to you, sure.
Okay, great.
Any other questions? I'd really, by the way, recommend to those of you who are interested in any more technical detail, I'd recommend that you could go to this website that will come back in a moment, I hope. There it was. These websites will all have more information. humetp.org, humtp.com. Democracy Counts is just a place where we put an occasional notice that something is available. TED Systems is my company name, but at mitchtrachtenberg.com you'll find links to a couple of documents that I've written first of all, trying to argue in favor of redundancy, which, I don't know why it's so hard, but trying to argue in favor of redundancy, and also laying out the ideas behind a lot of this program. It also has a document I wrote when we first discovered the problem in 2008 and what that experience was like. Yes?
I understand and really love the idea of scanning the ballots at the precincts on voting night.
Mm-hmm.
What would you do with the vote by mail ballots? Would they be scanned as they are opened? Because it seems to me the same idea that they need to be, the first time that they're handled, that they should be scanned.
That sounds good.
Yeah. Right,
I
because
agree.
it's, yeah. Right, thank you.
Thank you. Thanks a lot. Speak.
Speak.
So just to reiterate, I would really love to see something happen like this in Marin County. And we have a sign-up sheet in the back there, and we would love to have your name and email address, because you could also help, possibly be an observer of ballots being fed in, or you could possibly be part of a groundswell to perhaps get this kind of system happening here. And if that's of interest to you, when you sign your name in the back there, which we'd like your name anyway because we want to keep in touch with you as people are interested in integrity, election integrity, if you could just put a check mark or a yes or something by your name, because if we can get a few people asking Elaine, being that it's offered for free, maybe she'll go for it. And create a groundswell of interest. So that's what my hope is. And I guess, and we're also going to be creating other opportunities for people to create more election integrity. And we're in, for example, in the June 8th election, when Proposition 16 appeared to be winning, I went around between 10 and 12 at night to check vote totals. And that's what they're supposed to do by HAVA, have them posted at the precinct door, but they were only posted in about 30%. So I mentioned it to Elaine, and she said she was going to really try and get that more organized, because that creates a certain amount of additional safety too, and this will be an opportunity if people possibly want to do some of this as well. So, yeah.
No, I just wanted to say that also for the group here that it would be very good to put some visibility to the issue of observer access during the election at all parts of the election, because
yes,
the observers have had limited access in most of the elections, and I think even in Marin there's been a limited access in some, but certainly not in some areas of the election. The law specifically says that the public should have access to all parts of the election.
And that has been a very difficult issue.
Okay, and to Elaine, I'm on the Election Advisory Committee here in Marin County, and to Elaine's credit, at the Election Advisory Committees more than one time, and at several times during one meeting, she has said that anyone can come into her office anytime to observe the counting of ballots, and I assume she means the counting of absentees, when they open the absentee ballots, the signature verification. So any election observers can go to the Secretary of State site to look at the election observer plan that all the counties, including Marin, have submitted. but they also need to know that Elaine is on the record of saying that she welcomes anybody coming anytime to her office to look at how the election is being processed and the ballots are counted. So take her up on it.
Yeah.
Jim,
Yes?
in California and in Marin County, they've always honored, all of the certified parties have a legal right to watch the observations, and they don't take advantage of it. You know, some of them
That's
do on occasion. So, you know, you've got to become informed on what the rights are and then use them. If you choose not to use them, then you've chosen not to use them. And you shouldn't be up in arms when something else happens. You know, it's really rather fast.
And
So
it's not only
educating
being-
people about their rights is a big part of this.
Well, it's two things. It's being aware of your rights, and then it's being well-informed about what you're observing. Because if you call me in to look at brain surgery, you know, I mean, I'm your, or to look for weapons of mass destruction, you know, I'm your person because I know nothing about it. So you have to be informed of your rights, and you have to be well-informed about the process you were observing and evaluating.
But if
That's the critical part.
If I could just second what you were saying, though, I mean, one thing that is not happening enough is election integrity activists doing the grunt work. I mean, there's a lot of people who are going for the home runs, and I think we need to go for a lot more singles. And one person advised me somewhat with some annoyance, you mean you have never worked at a precinct for an election and threatened not to talk with me again until I had. So I did, and I learned a lot. And one of the things that you learn is that people are really, really trying hard in a lot of situations. And I understand the frustration on making that one mistake out of 10,000, and then everybody screams at you for that one mistake, but nobody was willing to help you do the 10,000. So I think people can really help things along by, in addition to being observers, by signing on to work at precincts. You'll learn a lot, and you'll also probably get some creds with the election officials.
Wow, that's wonderful.
Yes.
Yes.
We also, when we were talking to Deborah Bonus a few weeks ago, we talked to her about actually having a training program for observers. That would be a very
Oh,
good.
that's what, you talked to who about this?
Deborah Bonus about this.
Oh,
We
great.
talked about that there could be a program so that each county could have a system of training observers so that they would know what they're observing, rather than just going in and just looking and being present but not really having any kind of expertise. And then you would have a standard.
Of best
Yeah.
practices.
Yeah, that's wonderful, yeah.
In San Francisco, you observe from the other side of a red rope, and there's no way that you're, I've tried to observe. It's not something that I have access to seeing the folks as they're being counted or even really knowing exactly what they're doing. Even if I was trained, you're really kept away.
Yeah, that's true at Riverside too, where there's been an important lawsuit around.
No, I've looked at the
election.
election observer plans for all the counties are on the Secretary of State's website. As of 3 or 4 years ago, they were required to post it. Some counties don't have them. But I did read through San Francisco's, and what I found most amazing about all of them was that the public official is basically telling you what your rights are. You can be here, you can't be there, you can't. I mean, I think that whole proposition needs to be, needs to be addressed. The other thing that I noticed about Alameda County is that the ROV election observer plan is 6 pages, and the one that was produced by citizens, Michelle Gabriel, is about 1.5 inches thick. Well now, which do you think is going to be best practices for election observing? So that's just one other frontier of election access that we need to address.
Well, and then one of the things we talk about is everybody is eager to watch at a polling place during the day or to see those elections. But the absentee ballots take a week to count afterwards. And that would mean that somebody needs to be at the ROV's office or some clerk needs to be there.
Yes.
That would be
for a
great.
week.
Throughout the canvas process.
That it's not just that neat little thing about the night of elections. So it's a plan, a group.
What about observers, trained observers, observing the reconciling on the gems? That would be a good thing too, I would imagine. Yeah?
what fascinated me most about the presentation today was a systemic, transparent, feasible approach based on accessibility, transparency, redundancy, which has inherent in it no accusation to the process as is. And I'd rather work for the leap to that kind of parallel, integrity-based intervention or collaboration in the system rather than worry more about how to observe or validate how it's currently being done according to whatever rules may be followed county by county depending on the register of voters.
You can do both.
Excuse me? Yeah.
You can do both.
Well, you can do both, but I'm not interested in the observing part. What I'm totally intrigued by is a leap into another level of integrity-based validation, or in an era of technology and computer-driven processes and whatnot. And so now I live in San Jose, in Silicon Valley, and I'm on a large school board there as an elected official and involved in the politics of Silicon Valley and so on. I'm really glad Lori told me about this because I've never heard this presentation and it's totally fascinating to me. So the approach that I would tend to take would be to, if you try to work within the box that is there with its constraints and its practices and defaults and legalisms and whatnots, if you try to work within that box, you're going to go incrementally, sometimes, I mean, maybe even glacially, towards the kind of possibility that this is now offering. And I would rather step out of that box and work with the stakeholder leadership in any civic arena that can be persuaded to embrace the possibility and the necessity for this level of redundant verification, and that they would then capturing civic sensibility, especially among key stakeholders, would be leveraging through elected officials and in other words, you're not talking to the registrar of voters as your starting point. You're recontextualizing the conversation before you even engage the registrar of voters, so that what's coming at them is not you as an individual or 10 people who represent one group. It's going to be 50 people who represent various key constituencies surrounding that system.
I can't speak specifically to that, but I can suggest, and here's some unsolicited advice. The thing that strikes me as critical is clarification that ballots are public documents.
Exactly.
Yeah.
I think, I mean, I love
That's
that.
a law change.
I love that. I mean, that just rings democracy, from top to bottom, and all around.
Well, then that's the battle.
Yeah. I mean, there are principles there that will resonate with people, and I think the more you take it away from any hint of an accusation, I don't think it serves this cause to even allude to the Karl Roves or the what have you, because it stands on its own. The way to partner in a democracy, and an integrity process, it just stands on its own, so I'm really fascinated by this. I want to take it home.
Talk to your ROV or educate people in Santa Clara, or there is an election commission in Santa Clara.
If I were to do this in Santa Clara County, I would lay out a strategy similar to what I was just kind of overviewing before I even engage trying to get on the inside track.
I just want to say, I think what you just said, the second part about it standing on its own, independent of any fraud accusations, I think that's really critical.
Right.
Oh, absolutely.
And I think it's a problem in that people tend to be motivated around responding to incidents of alleged fraud.
Mm-hmm.
And I don't know how you...
Well, no, it's okay. People who are motivated by election fraud scenarios and realities and whatnot, great. They're motivated, but those aren't the people who are going to open the doors by themselves. They need to expand to that neutral center that doesn't operate out of that conspiracy or that even knowing of what may or may not have happened. You need that base in a representative nucleus of stakeholder leadership to sign on, and that base will sign on based on the integrity, you know, element of verification, quite apart from any element of suspicion. They'll sign on, you know, if you approach them with that, but most of the time people want to close the door when they start, you know, hearing directly, indirectly, implicitly, or explicitly some type of accusation or conspiratorial, you know, framework for why to engage.
Thank you for raising that.
You know, I really agree with you, Rachel.